So back to a familiar type of question. We have another example of solving an equation and its related inequalities analytically. And when I look at the type of equation and type of inequalities that are given to me, I know they are rational equation and rational inequalities. So they didn't specify in terms of the directions, but what they really mean when they say analytically is you are really using the sign analysis method. So one of the ways we can save ourselves a little bit of time and look at trying to maybe solve one of the inequalities first, because a lot of times when you solve for the boundary points, you will see which solutions you can include for part A, the equation. So I'll go that route. There are other ways to solve part A if you're interested. You probably reviewed it in the beginning of the section, but I'm just trying to give you a technique that may save just a little time. And we all like having more time on our hands, right? So we'll go with this. So I'm going to start off with inequality in B, just because that's the one in the middle. And what I want to do is remember that I'll write it over again for you. 4 over x minus 2 greater than or equal to 3 over x plus 5. Anytime we want to use the sign analysis method, we have to make sure we have a single fraction compared to 0. And when you look at the inequality that you have in part B, you're going to notice that this is a single fraction, but it's compared to another single fraction. So we don't have 0 yet. So the idea is we want to rewrite so that everything is on one side with 0 on the other. And how we do this is we subtract one of the fractions or one of the rational expressions from each side. So I like it better when I move everything to the left side. Saves me a little bit of confusion. So I encourage you to do the same. So if I was going to do this, I have 4 over x minus 2. That did not move. But the 3 over x minus 5, it was originally positive. If you were subtracting it from both sides, you would see a minus 3 over x plus 5. So at this point, we now have the inequality symbol compared to 0. So we're in pretty good shape. Keep in mind, though, we are not quite done. We can't quite move on to sign analysis because we have 2 fractions still. So this is a sum of 2 fractions or a sum of 2 rational expressions, or I should probably say difference, a little more exact. So in order for us to move on, we have to, again, maybe from the previous examples that you worked with, our job is to try to combine over a common denominator. So at this point, if you look at the 2 denominators, they are different. And in order for us to rewrite them so that they are combined over a common denominator, the first thing we have to note for ourselves is who the least common denominator would be. Well, when I look at these denominators, they're already as factored down as possible. They don't have any common factors, so the LCD is nice. You pretty much just push these together as factors, and you have your LCD. So when we're going through this mode, and I'm going to rewrite this over again just so that you see, our job is to be able to build 4 over x minus 2 up to a equivalent fraction such that it has the LCD as its denominator. So if I can see, here we go. I'm trying to get this x minus 2 over x plus 5. So right now, I see that it has an x minus 2 to begin with. The x minus 2 is going to need an x plus 5. So I'm going to have to multiply that by x plus 5 in the denominator. And then remember, when you are using fractions and you're multiplying the denominator by x plus 5, you're going to have to also multiply the numerator by the same thing. And If we do this, what we end up getting in the denominator, we end up getting x minus 2 over x plus 5. And if you'd like to, I encourage you, you could actually distribute the 4. 4 times x is 4x. And 4 times 5 is 20. It's positive 20. Now we're going to take care to do the same thing. Remember that these were two rational expressions or fractions being subtracted, so I'm still going to carry down the minus sign. Same story. We're starting off with 3 over x plus 5. And our job was to get it to look like the LCD. So already it has an x plus 5. So in order to make it look like the LCD, we have to multiply it by an x minus 2. If you do something to the denominator, you're going to do the same exact thing to the numerator so that you're building an equivalent fraction. And so at this point, you notice, okay, we have the x plus 5 times x minus 2 in the denominator. And we can do the same idea. We distribute the 3. So that's going to be 3 times x is 3x. 3 times negative 2 is negative 6. Just remember, the reason why we're doing this, we're trying to get a single fraction compared to 0. So I'll continue to rewrite the fact that I have not dealt with this greater than or equal to 0 yet. I want to not lose track of my end goal. So now, as you notice, you finally have rewritten each of the original fractions into equivalent fractions, having the LCD as its denominator. So we are almost there. What we now want to do is combine formally. So x minus 2 times x plus 5 is still the same thing as x plus 5 times x minus 2. So it doesn't matter which way you're writing or which version you choose. So we have that common denominator. And now we're looking at subtracting. So we have the 4x plus 20, subtracting off. And remember, maybe if you were watching the previous examples or you're working in your textbook, whenever you subtract something that has more than one term, you have to enclose it in parentheses to ensure that you are distributing that negative sign. So we're subtracting off the entire 3x minus 6. And again, we're still compared greater than or equal to 0. Now at this stage, we're almost there. The work leads us to saying, okay, how can we simplify this numerator? So that's the last thing, is just kind of making sure we're simplifying the numerator. And if we do that, the first thing we'd have to do is distribute the negative sign. So that'll be negative 3x, and then negative times negative, positive 6. And we're still rewriting the 4x plus 20 because we haven't used it yet. And notice the whole way through after this stage, your denominator is the same. And in some ways, I understand your hand is getting tired. It's a little rough to write, but it's really valuable that you continue rewriting it so that you don't forget it's there. That's kind of the #1 mistake we end up doing. We try to take shortcuts and then we lose that factor here and there. So I'm just trying to be consistent. The next thing we're going to do after we remove the parentheses by distribution, we are going to see if we can combine any like terms. So again, my denominator is still the same. I still have a greater than or equal to 0. But I have a 4x minus 3x, so that will give me an x. And then I have a 20 plus 6, so that should give me x plus 26. And so now I look at my remaining result, my inequality. I now have an inequality where I have a single fraction compared to, that's where the inequality symbol, 0. So that's what we needed to do. And it takes a little bit of a procedure to get there, but the time you spend doing this is going to be a lot more valuable because now you can quickly go through the sign analysis method. So we're going to repeat the sign analysis method from chapter 3 and even the previous examples we've done. We're going to look at, let me write this over again at the top. So we have the inequality. we have x plus 26 over x minus 2 times x plus 5 greater than or equal to 0. So a little bit of algebra tells us that we have our original inequality is equivalent to this inequality that's compared to 0. So I will do the same thing. First thing I want to understand is who are my boundary points. And with boundary points, we start off by setting the numerator equal to 0. And so that's x plus 26 equals 0. And so we get x equals negative 26. And then we go with the denominator. Set that equal to 0. Luckily, our denominator is already in factored form. If not, we would just factor it. And so from this, we do get two equivalent equations, or actually two resulting linear equations. X minus 2 equals 0, x plus 5 equals 0. So we should get x equals positive 2 or x equals negative 5. Now, this is where I want to pause and really analyze what is happening here. When we are dealing with this question of solving the equation and its related inequalities, when we found our boundary points, any values that make the numerator 0 will be the solutions to part A. So right away after doing this, we actually found part A solution. So x equals negative 26 is the solution to part A, since it is a solution to making the numerator equal to 0. And that's okay in rational expressions. Numerators can be 0. So you could either label it and point to it like I have done here, or sometimes if there's a place to enter it on your exam, or maybe you have to type it in depending on what format your exam is in. I might even write it by the problem. If I was going to look at part A, maybe I'll summarize up here for you all. So part A, my solution is just a single number, negative 26. So I can write it in braces. And if you just wanted to say simply x equals negative 26, that would be just as fine as well. So we already got part A out of the way. We're going to continue with part B. And before I move on, I also want to give you kind of an issue. And you've seen this issue all along. Anytime you have a fraction, so any fraction, if you saw something like, 9 over 0, remember that that gives you an undefined fraction. And with fractions and rational expressions, they're related. So remember that in rational expressions, the denominator is never allowed to be 0. It makes the rational expression undefined. So even though we have some boundary points, these will never be included. These make these values of x, make the denominator 0. So they cannot be included in the solution. And what we mean by including in the solution, boundary points work as such. They're bounds. Sometimes they are included, maybe in the last examples we were dealing with. And they talk about endpoints of regions. So we actually include them, but what we mean by included, I digress, you must use parentheses. And I should actually, it's plural. What I mean, those are parentheses. In the interval notation for these. So we will be including these in terms of describing what the regions are, but we have to use parentheses no matter what. So even though you kind of see that the inequality symbol was a greater than or equal to, and that usually makes you think about using a bracket. any value of x that makes a denominator 0 must not be included. You have to use parentheses. And if you want to like rewind just a little bit, I don't know if you remember, it's been a whole section now, and I know you've been practicing, but technically what they're trying to tell you here, they're not part of the solution. It's because these guys are vertical asymptotes. So we address them, but we know that the function will never cross those vertical asymptotes. So just wanted to try to make a connection to the previous section, and just really emphasize that you have to just kind of really be careful when you're trying to name everything and such. So that's why I kind of take a little more time on the boundary points. But having said that, we're now ready for that sine analysis, sine graph here. So let's do that. So I will draw it. I'm going to write my boundary points in relation to each other. So I have negative 26, 2, and negative 5. So kind of keep in mind you're graphing them in relation to each other. So I think negative 26 would be on the far left. Then comes along a negative 5. And then comes along a 2. And notice that they are not really drawn to scale. We're just doing them in relation to each other. So we have our number line broken up here. I believe now it's 4 different regions. Yes, 4 different regions. And if you would like to, just to kind of remind yourself that those are the boundary points, sometimes I make them stand out a little more. I then will take all of my factors from the numerator and denominator. So I have x plus 26. I'll write that on the far left. I have x minus 2. And I have an x plus 5. So I'm writing this all on the far left. This further subdivides our test region up a little bit more. So we have a few more regions to kind of test for ourselves. Now this is where, at this point, we probably have had a lot of practice. So maybe we can take a little bit of liberty and take this with some mental math. So I'll verbally explain this, but if you still want to write out the test points, no problem. The idea is that you're trying to be accurate anyways. So if I'm picking a number in the region that comes before x equals negative 26, this would be something like negative 27, negative 30. What I'd be looking at, I'd be testing. I'll just say x equals negative 30. It's a nice number that ends in 0. If I use negative 30 and I plug it into x plus 26, negative 30 plus 26 gives me a negative number. If I plug it into x minus 2, negative 30 minus 2 gives me a negative number. And if I plug it in to x plus 5, negative 30 plus 5 also gives me a negative number. I'll then move on. So I have to pick a number in the region in between negative 26 and negative 5. So let's say we pick negative 10. And I'm picking numbers that are a little quicker for me to mentally calculate. But of course, you can use your calculator to help as well. Negative 10 plus 26 gives me a positive number. Negative 10 minus 2 gives me a negative number. Negative 10 plus 5 gives me also a negative number. So I move forward. A number in between negative 5 and 2, I'll test x equals 0. That one's friendly. So 0 plus 26 is positive. 0 minus 2 is negative. 0 plus 5 is positive. A number after 2, let's check this out. Let's go with 3. Why not? So 3 plus 26 is positive. 3 minus 2 is positive. And 3 plus 5 is positive. So we have a sign for every single region and subdivision of each region so that we can now analyze what's happening. And so especially with these problems that have a lot of factors, remember that you don't want to write your factors too large so that they cover up a region and we forget to test it. Sometimes that happens. But now it's time for us to find the sign of each region. And remember, all these factors, they're either being multiplied or divided, so we can simply take the nice shortcut and multiply them vertically to get the sign of the region. So I'll start off. Negative times negative times negative gives us negative. Positive times negative is negative, but negative times negative is positive. Or you could have noticed, oh, even number of negative signs, we get a positive, and then you multiply that by a positive number, still positive. Same idea, positive times positive gives us negative, and positive times positive gives us positive. So that is what takes a lot of time. I do realize this, but your time is well spent because now you could answer part B. And let's remind ourselves, what was part B asking us? Part B was asking us, greater than or equal to 0, we're going to ask ourselves, where are we positive? So if we want to name that solution, let's see if I can highlight that in yellow. So we are positive in the region negative 26 to negative 5, and from 2 to infinity. So let's analyze this just a little bit. I'm going to rewrite it up here. We have negative 26 to negative 5. And let's remind ourselves, our inequality symbol is a greater than or equal to. So normally it does mean brackets, but we're only using brackets on the solution part. So numerator is allowed to be 0. The numerator solution gives us negative 26. There's a bracket we are using. And this is now where we have the cautionary tale. Took a little time. Anytime you're dealing with x equals 2 or x equals negative 5, they cannot be included in the solution. That's why this negative 5 will have a parenthesis, even though we saw a greater than or equal to symbol. These guys are, remember, the vertical asymptotes, or the values where they are, and they make a denominator 0. So this is why we have that parenthesis. I do know we skip a region, so there's a union symbol we're going to use. And we'll start up again at 2 and move all the way to infinity. So we go from 2 to infinity. I know infinities always have parentheses. And then another reminder, the 2 was not to be included in the solution because it makes a denominator 0. So this is why we have a parenthesis. So part B, we have our solution. Now, my friends, without doing any extra work, we now know we have a solution to part C as well. Remember, all that's happening and going from part B to part C is that the inequality symbol is reversed. So what we can look at, if we are trying to interpret this, we have an equivalent inequality expression that we already did all of the mathematics on, such that it's compared to 0, but we do have a greater than or equal to symbol. Excuse me. I guess I'm looking at the bottom of this. It is less than or equal to. Must be getting tired. You are too, probably, I'm sure. So less than or equal to 0. I'll emphasize that one more time. And that is asking us for part C, we want to know, where do we have a negative region? And so if you look with me at our nice little sine graph, our color codes, it's everywhere we did not shade yellow. We have a negative region from negative infinity to negative 26, and a negative region from negative 5 to 2. So we're going to include that in our solution. Negative infinity to negative 26. Infinities are allowed to have parentheses at all time. Negative 26 is allowed to be included because it's actually a solution. We skip, so we have a union. And then one more time, it's going from negative 5 to 2. So negative 5 to 2. And negative 5 and 2, they made the denominator equal to 0, so we have to use parentheses no matter what. So my friends, now you have the clear example of how to solve a rational equation and its related inequalities analytically. Really, if we try to do it graphically, we end up having a lot more issues. It seems complicated at first. Mainly, it looks like a lot of work based on the sign analysis, but I'm kind of counting on the fact you had some practice from chapter 3. So really, almost the brand new things that we're really dealing with in this section have a lot to do with recycling some of the algebra that we may have learned in the past, but maybe forgot. So this kind of is a little complicated. And then the other new thing in this section is being really careful about your boundary points, whether or not to use parentheses or brackets. So take some time on these. The more you practice, the more it becomes second nature. If there's anything I can do, please let me know. Hope this is helpful. I'll see you in the next section.